In this lecture, we're going to use linear equations to solve problems. So these are going to be application questions very similar to the ones that we did in the last video, but the equation was already given to you and the context. In this section, for the models and the applications, we're going to be given a verbal representation of a real world situation, and we're going to have to turn it into a mathematical model and solve it. So sometimes you're going to have to read the problem several times until you can state in your own words what is given and what the problem's looking for. So in other words, what should we let X be? What's the unknown? And then if necessary, we can write expressions for any other unknown quantities in the problem, but in terms of X, because if we're going to write one single equation, there can only be one variable in the equation. You can't have two different variables like an X and a Y. So we have to write the equation in terms of X. So what we're going to do is write an equation in X that models the verbal conditions of the problem or the written conditions of the problem. Then we could solve the equation and answer the question. And it's very important to go back to the original wording and check your solution. So we're going to do a couple of examples. So using linear equations to solve problems. So look at example 1. It says the median yearly before tax income of a full-time worker with a bachelor's degree exceeds that of a full-time worker with an associate's degree by 15,000. The median yearly before tax income of a full-time worker with a master's degree exceeds that of a full-time worker with an associate's degree by 30,000. Combined, 3 full-time workers with each one of these degrees or educational attainments earns 195,000 before taxes. So you want to find the median yearly before tax income of full-time workers with each of these levels of education. So in other words, you want to find the before tax income of a person with an associate degree, of a person with a bachelor's degree, and of a person with a master's degree. So it sounds like there's a lot going on here, but let's just kind of narrow down and I'll highlight within the problem the pieces of information that are given that are going to be important to us. So we know somebody with a bachelor's degree is going to exceed that of a full-time worker with an associate's degree by 15,000. We also know, so let me just change colors here, that the median yearly income of a full-time worker with a master's degree exceeds that of a full-time worker with an associate's degree, but by 30,000. Now, combined, these 3 different types of full-time workers earns 195,000, and of course, before taxes. So the question is, how much, what's the income of each one of these, full-time workers with that particular level of education? So a bachelor's degree earns 15,000 more than an associate's. And then a master's degree exceeds that of a full-time worker with an associate's by 30,000. So if we look at the yellow and the blue, right, one describes a bachelor's degree, the other describes the master's degree, but it's in terms of the associate degree. Each one is making a certain amount of dollars more than the person with the associate's degree. But we don't know how much a person with an associate's degree is making, so why don't we let that be X? So let X be the income, of course, of a full-time worker before taxes with associate degree. Now, in terms of X, how much does a person with a bachelor's degree earn? Will they exceed that of a person with an associate's degree by 15,000? So whatever they make, the person with the associates plus 15,000, this is going to be your income with a bachelor's degree. And we're also told that if you have a master's degree, that's going to exceed that of a full-time worker with an associate's degree by 30,000. So it's still all being compared to X, right? The person with an associate's degree. So X plus 30 is going to be the income with a master's degree. And in the pink highlight, it says all three full-time workers, with each of these degrees, earn 195,000 total. And again, before taxes. So the associate's income plus the bachelor's income plus the master's income should total 195,000. So the question is, what do each one of these full-time workers with this level of education, what do they make? So we need to solve for X, right? Once I know what X is, I can tell you how much a person with the associate's degree makes, with a bachelor's and with a master's. And we know that these total 195,000. So that means that X plus 15 plus X plus 30, right? Because those are my three incomes for each associate, bachelor, and master. That has to total or equal 195,000. Now, you see how we're assuming we're in thousands. So I'm not going to write the 3 zeros just to make it easier for us. But when I look at this, I know that that's 15,000, 30,000, 195,000, and X is in thousands. And we could add that on at the end. So we just set up an equation here that models the income based on degree. So let's solve for X now. So we could combine like terms, right? X plus X plus X is going to be 3X. And then 15 plus 30 is 45. And that should equal 195. We want to solve for X. So let's subtract 45. And we're going to get 3X equals 150. Now, if we solve for X, right, divide by 3. 150 divided by 3 is 50. So we're going to get X equals 50. Now remember, X stands for the income of a person with an associate's degree. So a person with an associate's degree is equal to X, which is equal to 50, and it's 1,000, right? So a person with an associate's degree makes 50,000. Now let's figure out what a person with the bachelor's degree makes. And that's going to be whatever X is plus 15. And we know X is 50. So 50 plus 15 is 65. So that's going to be 65,000. And now somebody with a master's degree is going to earn X plus 30, where X is 50, right? So it's going to be 50 plus 30, which is 80,000. So somebody with an associate's degree earns 50,000, bachelor's degree 65,000, and these are all averages, the median, which is an average, and a master's degree is 80,000. So this is the answer to our question. And you always want to go back and check your answer. So I'm not going to check my answer for every single one of these. You could always check your answers after the fact, but let's do it for this one. So we know that the total, right, of these three different incomes should add up to 195,000. So let's make sure that that makes sense, right? So in red, we'll check. So 50,000 plus 65,000 plus 80,000 should equal 195,000. And that does add up to 195, right? And we're in thousands. So always check your answers for reasonableness and make sure that they make sense in the context of the word problem. So let's look at the next example. So let's example 2. It says you drive up to a toll plaza and find booths with attendants where you can pay the toll by cash or credit card. With this option, the toll is $5 each time you cross the bridge. The attendant gives you the option of buying a barcoded decal for $25, and with this decal, you get 25% off the normal toll of $5 every time you cross. So find the number of times you would need to cross the bridge for the cost of the two options to be the same. Right? So option 1 is just pay $5 every time you cross the bridge. Option 2 is pay $25, but you're going to get 25% off each trip of $5 over the bridge. So how many times did you have to cross in order for these two options to be the same? So in order to figure that out, we need to let X stand for what we're trying to solve for, right? Which is the number of times that we would need to cross the bridge, right? And specifically for them, these costs to be equal. So let's let X be the number of times we cross the bridge. So now we need to come up with an equation to model this in terms of X. Well, there's two options, right? So with the first option, the toll is $5 every time we cross the bridge. But the other option, which I'll put in blue here, is for $25, we're going to get 25% off the normal toll of $5 every time we cross. So let's look. We have option 1, which is $5 every time we cross, and X is the number of times we cross the bridge, right? So option 1 is going to be 5 times X, right? $5 for every X, every time we cross the bridge. Option 2 is we're gonna, or plan 2, option 2, whatever you want to call it, is that we're gonna pay $25, but every time we cross, we're going to get 25% off the normal cost of $5. So 25% off means, right, out of 100% would be that we pay the full $5 every time. We're going to only be paying 75% of the $5, right? Because we're taking 25% off. So 100% minus 25% is 75%. So really, we're going to be taking 25 plus 75% of the $5 for every trip that we take, right? 5 times X. So the question is, how many times would we need to cross the bridge in order for these two options to be the same or to be equal? So we need to set these two options equal to one another. So when would 5x be equal to 25 plus 0.75 times 5 times x, right? Because either we pay, with the option on the left that I'm circling, we pay $5 every time we cross the bridge, so 5x. The other option is pay $25, right? Now to get this decal, this sticker, and then every time we cross the bridge, we're only going to pay 75% of the $5 for every trip, right? Because we're getting 25% off. So when would these two cost options be equal? So we set them equal to one another. So now let's simplify this, right? So we're going to get 5x is equal to 25 plus 0.75 times 5x, right? So we're going to get 3.75x. And now let's solve for x. Let's get x by itself on one side. So I'm going to subtract 3.75x from both sides. And 5 minus 3.75 is going to be 1.25x, and that's going to equal 25. And now we need to divide both sides by 1.25, right? Because we want to get 1x. So x is going to be equal to 25 divided by 1.25. And we get 20. Now, don't just circle your answer and say 20. That's 20 what, right? What are we solving for? X. And X represents the number of times we cross the bridge. So that's the number of times we would need to cross, 20. 20 times across the bridge. So always make sure that you label with the appropriate units. This is not dollars, right? This is the number of times that we would have to cross the bridge for these two cost options to be equal or the same. All right, so let's look at example 3. So example 3 says, after a 30% price reduction, you purchase a new laptop for $840. What was the laptop's price before the reduction? So we're trying to figure out what was the laptop's price before the reduction. So let's just let X be whatever we're trying to figure out, right? So X is going to be the laptop's price, right, before the reduction in price. So we know that we purchased the new laptop for $840. But that was after, so let's do a different color here, after a 30% price reduction. So that, let's set up an equation, right? So that 840 that we paid was the original price before reduction, right? Which was X dollars. We don't know what it is. That's what we're trying to figure out. Minus a 30% reduction in price, right? So minus 30% of the original price, or 30% of X. And whenever we take a percentage of something, we multiply. We multiply the percent by whatever we're taking, the percentage of, which in this case is X, because that was the original price before the reduction. So 30% is the same thing. So, right, 30% as a decimal is equal to 0.30. So we're starting with the original price, and then we subtracted 30% of that original price, or 0.30 times X, and that left us with a price of $840. So $840 is equal to the original price minus 30% of the original. And now we could figure out what that original price was before the reduction. Let's solve for X. So we're going to have 840 equals, think of this as 1x, right? 1x minus 0.30x is going to be 0.70x. And now we could divide both sides by 0.70. So we're going to take 840, divide by 0.70. And we get 1,200. And again, think about what that 1,200 represents. What are the units, right? It's price of the laptop before it was reduced. So it's $1,200. So that was the cost of the laptop before the price reduction.